Hi everyone, and today I'm proud to introduce you this LLM strict JSON framework, which I've been working on recently. So it has come to my attention that we kind of need to get consistent output from GPT-like models, and JSON seems to be a great way to do it. However, trying to get the GPT to output JSON isn't as easy as what we would like it to do. So there have been recent advancements like OpenAI functions, using Pydantic to try to get JSON out. But I still find this kind of methods kind of cumbersome, and also like LangChain also is a little too cumbersome. And that's why I decided to come up with my own framework. So let's take a look at what this is doing. So I'm going to run some cells. So just replace this with your own API key. My API key is here, hidden. So first, let's just use the normal chat function. This is just simply the normal OpenAI API chat call with the system to give like the system message to the GPT system, and the user is what the user types into the system. So we can ask like, oh, you're a friendly assistant, and then is the number 5 even or odd? And you can see that over here, they say number 5 is an odd number. So again, you see this is a bit verbose. If we want to use it for downstream applications, we kind of just want the number or want the category even or odd. And this is a bit hard to constrain GPT to output. So here I introduce you strict output formatting. So this is if you want to force GPT to output a certain JSON format. And actually, this helps a lot with minimizing unnecessary explanations of ChatGPT. And this framework also helps to ensure that all output fields are there. So I will not go into detail of this yet. Let's just see an example of how this does. All right. So if we want to just do an overall open-ended generation, okay, what we just need to take note is we just need to key in 3 things into this function. So actually, this entire framework right now is just one function. Okay, but eventually I will expand it to more things, like we can build on agents using this system. So this is the system prompt. Is basically what is the GPT's purpose in life, like what system you want it to fulfill. The user prompt is basically the input, the user input. So later when I expand this framework more to include functions, then this will be the function input. And the output format will be the JSON. All right, and this will specify the keys and values. The key will be the output field name. The value is the output description. So this is quite interesting because you can actually condition what you want the LLM to generate by just describing it in the output field here in the value. All right, the output keys will be preserved exactly. Okay, GPT will generate content to match the description as best as possible. So here I give you a text. Okay, this is a very familiar nursery rhyme. All right, and now what we want to do is we want to do something like extraction of information. So let's run this cell, and then what I want it to do is I want it to extract information from text. What information? The summary. We summarize the whole text in 10 words. The entity caught, okay, which is in this case the fish, because I caught the fish alive, right? The finger bitten. The finger bitten is actually a little finger, also on the right. And the numbers is the list of numbers in the rhyme. All right, so it's 1 to 10, exactly as what we see here. So this is if we want very general generation, we can just say exactly what headers we want and what kind of description of each header, and GPT will generate this exactly. All right, this is kind of ensured in this framework as much as possible. Okay, later I'll explain how this works. Okay, but we can also do quite interesting things, like we can do categorization. Like for example, if you want GPT to constrain within like 3 categories, you can just put it in a list over here, and GPT will try to output one of this list. Okay, so like over here, I'm so elated is happy. All right, so we can even change this to be like, you can change happy to be like joyful, and it will get you this as well. All right, so one thing about this is that this is not the kind of foolproof way to get a category all the time. Okay, because GPT is quite smart. If you output a category that it does not agree with, like all of these 3 categories or more, it does not agree with, then it will kind of change your category. Wait, let me just give you an example. Like for example, your finger bitten, it could be left, middle. Okay, but the correct answer is right. Okay, so let's just run this over here. So the entity caught is living or non-living. It's actually living because the fish is living. Okay, and the finger bitten, you see over here, they put it as right. Okay, so the reason why I did not constrain this is because actually GPT is quite smart. So usually the category that it gives out here is actually more accurate than the categories that you have given it. Okay, if it cannot match what you have given it, it will come up with what you want. Okay, but of course, I know sometimes in some use cases, we want an exact match. So what can we do? In this case, we can specify an input to this function called default category. And in this default category, you can specify what you want it to output if it's unable to classify it in one of these predefined categories. Like over here, I've given it unable to classify. And by doing so, when we run this cell, the finger bitten will be given as unable to classify. So later you can do post-processing. Maybe you can just do a random category and so on, because it means that these two are not correct. Of course, if you have given it like the word right, let's just take a look and see what happens. So you can see that if you have given it the right category, it would give you that category itself. Okay, so this default category is in case you want very strict applications of, like you definitely want one of the above cells. If not, your code won't run later for this classification. Then you should put a default category. All right. So next up, sometimes you don't want GPT to like output the whole thing like happy, sad, and you want it to just output the label. So I've also catered for that as well. Okay, so you can just do it in this format. Like you can do a.happy. All right. At the back end, actually, what this happens is we actually, let me just show you. You can just type in the verbose option to be true. And then you can see like this is what happens. Like this is the system prompt. You are a friendly assistant meant to extract information from text. You're meant to output the following JSON format. All right. And these are some instructions. Like if the output field is a list, classify the output into the best element of the list. The user prompt is this. And the GPT response is actually this sentiment a.happy. So this is actually quite good because when the GPT outputs like that, in the function itself, it will just truncate it to A. All right. So this is in case if you want the output to be of a certain category, then you can do something like that. All right. So you can also see like how this is done. Like over here, finger bitten A, left, B, middle. You realize that the output here is A. Okay, but if you want it to be like, well, you see this is left. Okay, actually, let me just show you how this works. If we put verbose is true, it becomes like this. It will become finger bitten is A, right. Okay, actually they converted the category to the most like semantic meaningful stuff, which is left. So over here, if we don't want it to like output something that is different, okay, what you should do again is to just say unable to classify. So this is what happens if I do it. All right. And the finger bitten here would be unable to classify because it did not match one of the categories I've given. Okay, this is actually quite good. I've tested this quite extensively, and this format works very well for doing the like different labels. In fact, if your labels have some semantic meaning, this is even better because it can help with the classification better. All right. So I added a bit of cool stuff here. So like sometimes we do not want the input or the output format to be too exact. We want it to be fixed, but we want certain things to be modified. So for example, we want like entity bit my entity. Like we want GPT to replace only stuff inside this angle brackets. All right. So I've catered for in this framework. If you just put something in angle brackets, the stuff that you do not put in this angle brackets will be preserved exactly, while the stuff in angle brackets would be composed by GPT to be the most, something that is most plausible. All right. So you can even do the angle brackets as a header. All right. But if you do as a header, just take note that this framework will not be able to ensure that this is always present in the output. Okay. Because if this is conditional on the GPT generation, there's no way to know like whether or not this matches with whatever you type here. All right. So you will lose out on that, but you will gain in terms of flexibility of the header names being adapted to your circumstance. Like over here, the location of injury might change for each output, all right, or for each text by the user. Okay, and you can just condition this like that. Right. So let's run this, and you can see like summary. All right, the fish bit my finger, so that's great. Entity bit my entity, exactly preserved. I mean, if you say nibbled on, all right, you can see that fish nibbled on my finger is exactly preserved. So that's great. The entity caught living, yeah, that's correct. Location of injury, the fish caused the injury. So we have, you see, the location of injury here is little finger. And then you can see that this is like the entity caused the injury. you can also modify this to be like that injury was caused by entity. And then you can see like at the output, injury was caused by fish. So this can help you preserve some text that you want and change only the text that like you want it to be dynamic. So this has quite a lot of use cases. Okay, I did it because I needed to use it. Right, so one good thing about this framework is that you can actually use the JSON output to do chain of thought. I mean, who would have thought that, right? So like, for example, if I want to do an LM planner, and this is like what I want to do, okay, and these are the constraints, like plan my day. So if let's say I want to do like detailed plan, okay, I can just do it like one output detailed plan over here, hourly base schedule. And over here, you can see the detailed plan is kind of wrong because 12 to 3 is a webinar, 3 hours webinar, correct? 3 to 5 is a board game session. That's wrong because I want a 3-hour board game session. So sometimes if you ask it to generate the detailed plan straight away, it does not do so that well. So what we can do is we can ask it to do a step-by-step chain of thought generation. You can ask it to do the broad generation to come up with the broad plan first. Then you go to the detailed plan, okay? Because if we go to the detailed plan, condition on the broad plan, we get better generation. Okay, in my experiments with the abstraction and reasoning corpus, this kind of broad and detailed works wonders. So let's just take a look at how it generates. So if we run this, wait a while for GPT to generate the output. Okay, so this you can see that it has gotten the webinar correct and the board games correct as well, 4 to 7. So it's 3 hours. So just by conditioning on the broad plan first, okay, if you put the broad plan as the first tag to output for the JSON, when you generate the stuff for the detailed plan, the information from the broad plan would already be present for GPT. So this is how it works quite well. Right, so you can use it to do step-by-step chain of thought prompting by giving the text in output format in the correct order. And best of all, you can even describe what kind of stuff you want to generate in the value. I really like this, this way of doing things. Yeah. So this is just an example of how to generate stuff for like reinforcement learning. Okay, so this is actually inspired by Seiken, which is a high-level planning language. So we have a robot starting at area A, John at area B, and the can of Coke at area C. Okay, and the robot basically needs to fulfill a task. Okay, you have to choose an action to bring you closer to accomplish your task. So the constraints is you need to pick, you can pick up the objects in area if you go there, but you need to pass explicitly, and you must be in the same area. All right, pass the object. So the user prompt will be the current state and the past action. So the current state will be based on like this new state, which is given from like, because this takes a few steps. Okay, so what we'll do is we'll reiterate the current state. I'm using the React framework. So first we have the thoughts, okay, the action, which is like, again, you need to like do some form of classification of the action. And again, you can see I'm using the label and the description format. So in the label, you can say like what kind of action you want it to do. And over here, you can, in the value, you can put the description of the action that you are doing. So over here, the narration of robot doing one action, and then you describe like what this narration is. So this is the kind of format that we have in this framework all along. So the React framework thoughts, action, observation. So this is by right observation that should be generated by the environment. But here I'm getting GPT to generate the observation as well. So I did some thoughts processing by saying, okay, what happens after I do one action and what's the new state? Then I reflect on whether or not like the output has been completed. So it can give a self-reward signal. And then I finally say task completed, yes or no. So if the task is completed, I break. That means we are done, right? Furthermore, I also give it like the past actions here. So I add in the actions here. So this is like some memory of what it has done before. So we can see what happens. Okay, for the first one, the robot say to give a can of Coke to John, I need to pick up the can from area C, then move to area B where John is located. Bravo, it has got the whole plan out. So the first action is move to area C. So after that, the robot picked up, moved to area C to pick up the can of Coke. The new state will be robot at area C, John area B, can of Coke at robot. That's great. All right, task completed, no. So we continue. The next action is move to area B. Okay, and then they say that, okay, however, I still need to pass the can of Coke to John. That's great. Task completed is no. All right, so next we have the robot at area B, John at area B, and can of Coke at robot. So the thoughts is that I need to pass the Coke. Okay, so action is pass Coke of can of Coke to John, and that's great as well because the new state is can of Coke now at John, and the task is now completed. So you have the entire thing Okay, you have the entire thing that basically says that, we have completed everything and we can move on. That's great. Okay, so now next we have the handling input as a list format. And the reason why I decided to do this is because sometimes you want to classify many different kinds of inputs at the same time so as to save some tokens. So I have catered this in the framework as well. If you put your user prompt as a list, okay, the output will be a list of the JSONs. So like initially, the first few examples I've shown, like I only gave this part without the list, right? So it only gave one JSON. But if I give like this as a list of inputs, the output will then be a list of JSON. You do not have to repeat like the input text many times, okay? Like for example, if your system prompt here is like do some form of like your system prompt, your output format could like tell you like a lot about the labels and everything. Sometimes it's very lengthy because your classification is a very lengthy one. You don't want to repeat that all the time. So you can do this and then you can save some tokens. So let's just run this and see what happens. So here we can get sentiment happy, sentiment sad, sentiment boring, which is corresponding to this. Beautiful day is happy, heart is aching is sad, time is passing by so slowly, it's boring. So that's great. You see, you can do all at one go. All right. I mean, I can just show you how it works back end. So if we set verbose is true, okay, we can straight away see like what is happening is that this is output in this format, okay, and then generate a list of JSON, one JSON for each input element. And you can see that this is like the user prompt and the output GPT response is like that. All right, we can also do this using whatever we learned earlier, like the dynamic entries. So over here, we can do like labels like that. And then we can also do like this main entity name. Okay, so sometimes you see this does not generate. Okay, so we might need to like condition this name of main entity. Okay, or sometimes we can just put main entity. So this one, if you use angle brackets, you must take note because this means that I cannot ensure that this will be out. So main entity works. So you have to kind of configure this for your use case. So like over here, beautiful day is the main entity for this one. Heart is the main entity for the second one. And the last one, the main entity is time. And then we can also like describe the definition of it. So you can ask GPT to generate this. So this is very cool because sometimes you want this to come up with like the entities for your, or some objects for your input, but you don't exactly know beforehand. So you can do that. Okay, but there's a slight risk here because I cannot ensure that this will always be generated if you do angle brackets like that in the keys. Okay, if you do angle brackets in the description, that's not a problem. All right. So last but not least, okay, we can also say instead of like doing like A, B, C, like for example here, sentiment C, sentiment A, sentiment B, sometimes we want to do away with the values, with the keys. So what we can do is we can just say output value only, we set it to be true. Then you end up with a list of classifications. So then you can proceed to use this for your other purposes. So yeah, this is more or less the overview of the framework. So far, it's only one function, which is called straight output. I intend to expand it to do functions, intend to expand it to do agents as well with various tool use. And if this works out well, I will also integrate this with the symbolic AI framework that I've been talking about these few days. So you must be interested how this works. Okay, I haven't explained how this works yet. So let's move on to it, shall we? So let's go up and see how the magic works over here. Okay, so this is the straight output function. Okay, it takes in the system prompt, user prompt, output format. Okay, and then you've seen some of the other stuff as well, like default category, output value only, verbose. Okay, so the model here, I use GPT 3.5 Turbo, which is about like 0.2 cents per 1K tokens. So like running this whole notebook will be less than 1 cent. So I quite like this a lot. So all these prompts are fine-tuned on this model so that it's cheaper for you to run it. Okay, so what we will do is, like, firstly, okay, we will look at the whole general idea is that we will use a rules-based feedback to ensure that GPT like give some hints to GPT saying that, hey, your JSON output is slightly wrong, so you can, this is the error message, try to correct it. So it's like using the iterative environment feedback, like what Voyager is doing. And the environment here is getting the output to be of the correct format. So if using that, we can try, like, I think normally two tries would be enough, but you can set it to 3 or 4 tries if, if it's not getting it. All right. So if it's unable to get the strict output format, it will just return an empty JSON. So you can then use this as the trigger to do a default output. Okay, that means the GPT is unable to get the JSON format as required. Okay, but most cases, if you do the right kind of formatting, okay, the JSON format would be generated. Okay, so if the output field is a list, okay, we will treat it as a classification problem. And text enclosed within this brackets, angle brackets, will be generated by GPT. So this is the flexible context I'm talking about earlier. So first, we do some checks to see whether is there a list, is there dynamic elements, and also is there like first is the user prompt a list, and the last one is whether or not the output format, the JSON output you want, contains list. Okay, because if it contains either of them, all right, I'm going to prompt it differently. Okay, there's more prompts if we have all these instances. Initially, we have no error message. Okay, only later on, if there's a problem, then we'll add the error message. So the initial output format prompt is you are supposed to output the following JSON format. Okay, then we put in the output format that the user provides. Do not put quotation marks or escape characters because it's not really accepted by JSON. All right, so if there's a list input, so the output field is a list, classify. Okay, so we just prompt it to classify. Just a 0-shot prompt like that will work already. Okay, if the output element contains a bracket, indicates you must generate content to replace it. Okay, so this one GPT wasn't that great, so I had to do a 1-shot kind of prompting here to tell it how to do for like values and how to do for keys. So you can see like this is like what exactly is done. It works quite well. Okay, this key one sometimes doesn't work. Okay, so you just use it with caution. If the input is in the list format, we can generate a list of JSON, 1 JSON for each element. So this one is the multi input so that you can save some tokens. Right, so we then pass the thing to OpenAI, and here we put the system prompt, output format prompt plus error message. So this will be the system, and the user will be the user prompt. Okay, so here I'm putting a string because sometimes the user prompt can be a list. Okay, so I need to convert the string because OpenAI only accepts strings. So we basically, when it comes out, the output from OpenAI will give this single quotes. So we make it a double quotes because JSON needs double quotes for the keys and values. Okay, and then in case we don't sub like stuff like I'm, they are, if there's a letter before and after a single apostrophe, before a double apostrophe, we change it back to single apostrophe. So this using regex. Okay, if verbose, we print it out. Okay, this is the crux of the method. Okay, so this is the try catch block to ensure that we have the strict JSON format. So first we try to load it. Okay, of course, if this fails, then there will be an error message returned. Okay, but if let's say this can be passed, I mean it's a valid JSON. Okay, then we check whether is it a list of JSON. Okay, if the user prompt is a list, the output must be a list. If not, we say output format not in a list of JSON. All right. Otherwise, we make the single JSON become a list of JSON also. So we can do the processing the same. Now, how do we process this? For every single element in the list, okay, we check for the output format keys. Okay, make sure that all of these keys appear, okay, in the JSON that was outputted by GPT. So again, if the key contains a dynamic entry, we can't really check it because we don't know for sure what the entry is, so we can skip it. Okay, but if it's not a dynamic entry, if there's this key that is not appearing in the output, then we can just say key not in output. So these very informative error messages are important because this helps to condition the generation later. Okay, then we check whether or not one of the choices given for the list of words, is it unknown or known? Okay, so if let's say one of the choices is unknown, all right, so basically we have the list of choices. If let's say it's in a list, okay, we already have all the lists here, and then what we will do is to ensure, okay, that the output generated, all right, firstly, it's not in a list, it's in a value, because like, for example, if we want, let's go here. If we want stuff like this, like joyful, sad, neutral, we don't want the output to be like in a list here. We want it to be just like joyful without the square brackets. So this part here will take away the square brackets if GPT accidentally generates wrongly. All right, next, we output the default category if GPT is unable to identify it. So if let's say the value here is not in the original list itself, okay, then we will just go by default category. Then we will say that, okay, this is the default category because it did not identify it correctly, so you will use this. Okay, but if you do angle brackets, right, then for the value here, we cannot use default category, because like, if you do angle brackets, we have no idea what it will generate. So default category only applies if you don't do the dynamic prompting. All right, then next, if the output is a description format, which is the label and the description, we basically just do post-processing. So we just take the ... and then we just split and take the first part, which is a label. So for GPT, it's actually generating like a ... happy. It generates the whole thing. Yeah, because generating the whole thing actually helps it a lot more than just generating that label. So this one is, unfortunately, is for performance. Okay, so we sacrifice a bit of the tokens, but the output will be curated by some rule-based stuff. Okay, if let's say we say that we only want the output value without the headers for the JSON, we can then process it as such. Okay, we can just take away all the headers. And if there's only one single output, then we don't even need the brackets. We can just output like A, B, C, like in a list. Okay, and then we return the output as a JSON. So this will be the output format. Okay, return the output as a JSON unless it's this output value only, then it will be returned as a list. Okay, so all this is a little confusing. I think it's easier to just take a look at the examples, what it's doing. Okay, but this is the crux here. Okay, if let's say there's a problem with the JSON, okay, we will say that this was the JSON you output, or this was the output that came out, and this is the error message that I'm giving you. So the error message is based on what exactly went wrong. Okay, and then I will just say, okay, use this in the next iteration. Okay, use this to put in the system prompts. Okay, where is it? Here, so that GPT would do self-error correcting. Right, cool, right? Just a very simple idea. All right. So if let's say after a while it fails, you just return an empty JSON like that. So cool. Yeah, that's all for the format. Do try it out. Let me know. All right. I'm actually quite keen to work on implementing it more and do agent-based stuff. And as you can see, like it kind of works pretty well if we do like a secant kind of thing already, just by doing like chain of thought prompting, just using JSON. Okay, and the benefit of that is that you can even constrain what you want to do here. All right. So there's a lot of possibilities that can be done with this framework. I mean, if you want to do like stuff like few shot prompting, you should do it as part of the system prompt. Okay, I did not create a few shot here because you can just add on to your system prompt. So there's quite a lot of possibilities already that you can do with it. And yeah, do let me know if you have any other suggestions to improve this. My aim is to make this lightweight without a lot of extra baggage. Okay, the aim is just to get it to generate JSON properly. And yeah, there's quite a lot of things that were already implemented, like dynamic, the dynamic generation is actually for RL stuff, because like sometimes your action, you don't really have the object in mind. So you have to do this kind of stuff. And then you can even say that, oh, action move to area C. It can even give you actions. If you do like the up challenge, then this angle brackets can be like the function inputs that it needs. Yeah, so the actions can also be calling like tools, calling functions. So I can see a lot of potential extensions to this. And yep, so it's a long video already. That's it for now. And I'm looking forward to share more about the functions and the agents framework, extending this shortly. All right, see ya.